Okay, introduction to amines then. We're going to start off with the classifications. So amines can be classified as primary, and if it is a primary, then we have a nitrogen with two hydrogens and an R group on there. So typical structures for these, so CH3, NH2, so just the one R group here means that is going to be a primary structure. Other examples, if I do an arene version of that, so NH2 again, so on the nitrogen, on each of these there's one R group coming off. So this one's called methylamine, and this one is called phenylamine. So with benzene, it takes on its alter ego, its different name, so phenylamine. Okay, so secondary then. So if we start with the trigonal pyramidal arrangement around here, so two of these now are going to have R groups. So that is where we get our secondary one from. So again, we could have something like this. So hydrogen here. The R groups don't have to be the same. So we start with the longest chain, which is 3, so that will be propylamine. And we use the N like we use a number, so N-methyl propylamine is how we would name that one, okay? Another example. So CH2 to CH2, CH3 with a hydrogen here. So again, propylamine is the longest in here. So move that up, I'm struggling to get my pen to work. So propylamine, and this time I would have an N-ethyl. Okay, and with my tertiary now, so again, I've got a nitrogen at the top here, and all three of these are going to have R groups on the end of them. The R groups can be the same or they can be different, so you'll very often see a kind of dash and dash dash to signify that they are different. So, simple example. Oops. I could have 3 the same on there, and that would be simply trimethylamine. Or I could have one that is different, so CH3 and CH3, and then down here, so CH2, CH3. And the longest chain is ethylamine, so it's going to be called ethylamine. And then I've got 2 methyls, both of which are on the end, so it's NN, because we use the N like we use numbers, dimethyl ethylamine. Okay, let's move on. So isomers then of 3 of these, 3 carbons in here, so CH3, CH2, CH2, NH2, so 1, 2, 3, and then a 4th one to NH2 here. Again, just moving the nitrogen along a little bit really here, so CH3, that will give me that, and then obviously I can have tertiary, CH3, CH3, and then there's loads of different ones that we can get. So if I draw this one, so CH3, CH2, NH, and then CH3, and then with this one CH3 to an N, to another CH3, to another CH3 there. Okay, so this one will be primary, this one will be secondary, and this one will be tertiary. And as we've already said, with aromatic amines, the benzene ring takes on the name phenyl, so phenylamine. So with the aromatic amines, obviously the way that we do that is we use tin catalyst, concentrated HCl, and we reflux. So this is in the aromatic pack. So we start with a nitrobenzene, and that's our reduction mixture with 6 H's, which then gives us NH2. So the 2 oxygens that came off are going to form water, so I need 2 of them. So I've got 4 hydrogens here and 2 there, which is why I need 6 here. Okay, and this is a reduction reaction. And we tend to use these in the manufacture of dyes. So amines tend to be used in the manufacture of dye stuff. Okay. So, right, next page, just looking at the aliphatic amines. So the general formula for these is CnH2n plus 3. That should be a 2 plus 3. And then an N. So from the halogenoalkane, so there's obviously 3 ways we can make them. So there's one which is the reduction of the NO2, giving you the aromatic amines, which we've just done. 2 is using the halogenoalkanes, and the third one is from the nitriles, using the CN that we've done. In, for example, the aldehydes and ketones reacting with KCN and acid to give the CN group. But anyway, let's start with the halogenoalkane. So obviously there's our halogenoalkane. We react that with ammonia, and that is going to give us our amine. So here's what happens. The R group on the halogenoalkane replaces one of the hydrogens in the amine. And then when we look at the mechanism, it becomes a little bit easier to kind of see how this is happening. A second one of these is used to remove the additional hydrogen. I've got too many hydrogens there. To remove the third hydrogen from there, which will then give us NH4 plus and X minus. That's easier to see in the mechanism. So if we just look at a mechanism with the halogenoalkane, so NH3, there's a lone pair, curly arrow from there to there because that is D plus, and the nitrogen is D minus, and then that bond breaks there because that is D minus. That gives us an intermediate. So the chlorine is gone, so I'm just going to move that hydrogen up there. There's the hydrogen. And then the dative covalent bond from the nitrogen means that nitrogen is going to have a positive charge. And this is where that second ammonia comes in. Now, we generally don't do it in our mechanisms. So generally, we just take one of the nitrogen-hydrogen bonds and go back to that. But what you'll see in some of the mark schemes and stuff is that we have a second ammonia there that actually is used to remove that hydrogen. I wouldn't put that into mechanisms. I'm just explaining to you really why we have the 2 ammonias here. So this then gives us our final product, which is our amine. So there's our amine. But of course, that additional one in green, that's now formed an NH4 plus, and with the chlorine that came off in step 1, that's what we get there. Okay, so all of these reactions are nucleophilic substitution reactions, and when we're doing these reactions here, you just need to remember when we're doing the balanced chemical equations, we need 2 for every halogen that we've got. So because I've got 2 halogens in there, I'm going to need 4 in that one there. So that's going to give me CH3, CH2, N, because remember it replaces one of the hydrogens there. And then I'm also going to have NH4, Br. And then with this one, so that's going to take up one of the positions in the ammonia. And then the second one is going to give me NH4, Cl. And then in this one, so I'll start with the backbone from here to here. So I'm going up, down, up, and then up to an NH2 there. Oops. And then down to an NH2 there. And then I'm going to have 2 NH4 Cls in order to balance all of that out. Okay, so hopefully you've got those right, yeah, there we go.